A sand layer found at seafloor under a 20-meter water depth is characterized with relative density 40%, maximum void ratio 1, minimum void ratio 0.5, specific gravity of the solids 2.67. Assume the specific gravity of seawater to be 1.03 and unit weight of fresh water to be 9.81 kilonewton per meter cube. So, what would be the change in the effective stress rounded off to the nearest integer value of kPa at 30-meter depth into the sand layer if the seawater level permanently rises by 2 meter? So, here it is said what will be the change in the effective stress you have to find out at so and so depth if the seawater level permanently rises by 2 meters. So where is the seawater level? Seawater level is 20-meter above the seabed. So, to draw that, so there is some seawater above it. This is 20-meter. Okay. So he asks at a depth of 30-meter in the seabed. This is seabed. Okay. This is seabed. Okay. This is water. Now, see, at any already the water table is above the seabed. Now, if you talk about the effective stress at any point P, let us say effective stress at P, this point, total stress is at P minus pore water pressure. So UP, let us say. Okay. Now, whenever you are increasing by 2 meter permanently, so it is increased. Okay. That is what. If the increase happen, so what will be the change in the effective stress? So due to that increment, how much total stress will increase? How much will increase? See, this is intact. The water up to this level is intact. The total stress will increase by this much water. So, what is that stress which is increased by increasing the height of 2 meter water height? So, that is nothing but gamma of, let us say if it is seawater, gamma of seawater into 2. This will be increased by this much. Okay. 2 is the height, gamma seawater is the unit weight of the water. So total effective stress is increased by this much because remaining things are same before increment up to here. Now, and how much pore water pressure will be increased? Pore water pressure also, if you put a tube, and so before increment it will be up to here pore water pressure. Okay, from here, after increment of the water, after increasing the level of the water, the pore water pressure will also increase by the same amount, right? Because the water height, it's at the end it is water, so that is also uh, for this plus. Okay, gamma of seawater into again same. So the increment in total stress and uh, water pressure, pore water pressure, both are same due to the increase in the height of the water. Okay, that too above the seabed. So if it is well below the seabed, suppose if it was somewhere here water table, if it is raised by 2 meters, again still it is well below the seabed, let us say it is increased up from here to here, then the effective stress will change. But now we are talking about the increment in the water level that is happening only above the seabed. Okay, it is already fully saturated, there is no change in the saturation of the seabed. That is the reason why the increment is same in total stress and pore water pressure. So when it is the same, if you deduct, then effective stress will not change, that will be unchanged. Okay, so that is the reason why the answer is, what would be the change in the effective stress? That answer is B. There is no change in the effective stress. Answer is B. Thank you.